right. Good morning, everyone. I was expecting much less number of people because I think this is not the, easiest timing to attend the session right after the big party last night. So thank you for joining me this morning. Today, I'm going to introduce our new haptic glove, TactGlove DK3, which was just unveiled for the first time at the AWE here. And also, I will share more about the various engineering or technologies behind it, and also the story behind some of the important decisions we made while developing TactGlove DK3. Throughout the session, I hope you will not only gain a better understanding of TactGlove DK3, but also learn more about key considerations required when you are developing haptic gloves. So let's start here. Let me briefly introduce myself first here. So I co-founded bHaptics in 2015 with two of my friends from the university. At the time of founding, I was finishing my PhD in haptics, with major in haptics and brain-computer interface, BCI. Like many others in our field, I was so motivated to start a company while doing various experiments with Oculus DK1. So 12 years ago, in 2014, I built prototypes of haptic suit and haptic glove that bHaptics sells today. And I hooked them up to a simple FPS gaming demo that I created myself. And that experience was convincing enough to me to start the company. As you can see in the picture here, at the very beginning, we didn't have a vest. Honestly, I thought maybe wearing a haptic vest would be too much for gaming, but that exact product, the tac suit, ended up being the best-selling, the most popular product in our company. So 1 year after this photo was taken, I started the company, and it's already been 11 years. So last month, we created a short video to celebrate our 11th anniversary. So let's take a look. So, today's presentation, I'll focus more on the haptic glove, but as you just saw in the video, we are not only making the haptic gloves, but also the haptic suit called Tac Suit Pro and Air, and the haptic sleeve called Tac Sleeve. So, if you have time after the session, please come to our booth at the floor to try all those demos. All right, let's go back to the hand. The hand is obviously the most important part for feeling touch, but we didn't build a haptic glove first. The reason is that to deliver haptic feedback to your hand, you first needed a reliable hand tracking first. Because human hands move so freely, over 24 DOF, achieving this reliable hand tracking is extremely expensive actually. However, since the Meta introduced the the camera-based hand tracking to MetaQuest 2 in 2019, now users can enjoy their XR experience, XR content with their own hands, like very easily without any extra cost. And the Apple Vision Pro and Galaxy XR adopted the same approach. So therefore, now we can imagine that there would be more people will use their own hands to interact with the virtual object in XR or spatial computing environment. However, when you actually move your hand to grab an object, you feel nothing but just air. The immersion drops significantly, and that is exactly why we started developing the TactGlove in 2019. So our first product, TactGlove DK3, was unveiled at CES 2022. It used only one motor per finger pad and the same motor on the wrist. Actually, the most difficult part of developing the TactGlove was that it had to fit extremely tightly to your hand because it needed to be reliably tracked by the camera-based hand tracking. So it just looked like the bare hand, even though you are wearing the haptic glove. So it was very challenging for us to develop a well-fitted structure while placing a motor on the finger pad and routing the internal wire from the finger pad to the wrist all the way down to the wrist throughout the back of your hand. So in addition, we had to make 4 different sizes of the haptic glove, which we really hate to do that, but we had no choice but to have 4 different sizes because there are like so many different sizes of a hand. And TactGlove 2 was barely TactGlove DK2 had the same motor type and the placement as the DK1, but we just improved the structure for easier manufacturing and improve the wearability by changing some of the fabrics to more stretchable and adopted this magnetic wrist strap. But after releasing after releasing the TactGlove DK2, we kind of thought, okay, now it's time to focus more on the haptic feedback, the quality of the haptic feedback. So internally, we built a prototype of a haptic glove that has 16 motors, as shown in the picture, to test how much immersion could be enhanced depending on the location and the number of motors on the hand. So we placed 5 motors on the finger pad and 5 motors on the nail area, and 4 on the palm, and 1 on the bottom of the wrist, and the other, the one on the top of the wrist. The result was, first, surprisingly, the perceptual difference between the motors on the finger pad and then motors on the nail area was not big enough. So people, when there's it was kind of hard to tell the difference between the motors on the finger pad and the nail area. However, when you have motors on the nail area, the vibration of the motor and the nail part occasionally interfere with each other, so it just caused unpleasant feeling sometimes. So we decided to not to have motors on the nail area. And when we moved the motors of the nail area to the middle of the finger, and when we try that and compare the immersion, the level of the immersion with the motors on the finger pad, we found that, well, even though it was just an inch away from the nail area, the immersion degraded like too much. So we could not have it just felt unreal when you are interacting with the virtual hand, with the virtual object with your hand. So we ended up having models on the finger pad only. And that was that. And for the palm, we found that even just one or two models on the palm really improved the overall immersion vastly. Obviously, when we have 4 models just like that, it just delivers the maximum immersion. However, we ultimately had to get rid of the 2 models on the middle, because when you fold your hand, it was really hard to to maintain the contact of the 2 motors in the middle when you fold your hand. So we ended up having only 2 motors on the bottom of the palm. And the motors at the bottom of the wrist really delivered a unique feeling, but we found that there would not be that many applications that requires that kind of sensation, and also we needed a space for equipping the battery of the TactGlove. So we get rid of the motors on the bottom of the wrist. But on the other hand, for the top of the wrist, the vibration created at that location, top of the wrist, really actually affect to the entire hand, not only the wrist part, but it kind of propagate through the entire hand. So we decided to have a more advanced motor with higher fidelity. So in TactGlove DK3, we applied 1 vibration motor for each finger pad and 2 for the palm. And additionally, we added high fidelity motor on the wrist area developed by the Titan Haptics. As a result, while we can only control the intensity of for the motors on the finger pad and the palm, we only can control the intensity of the motor, intensity of the vibration. But for the wrist motors, we can control not only the intensity but also the frequencies too, so that you can control from 1 Hz to 100 Hz. However, in the TactGlove DK3, as you can see, there's a wide empty space between the finger pad motor and the palm motors. However, as I mentioned previously, it is very difficult to add some other more actuators in between the palm and the finger pad. Therefore, in the TactGlove DK3, we embedded a special algorithm that can create a haptic illusion in between the motors, so that kind of it fills up the empty space by controlling the multiple actuators at the same time. This algorithm is based on the tactile 5 phenomenon, or phantom sensation, which is well known in the haptics field. So when the intensity of the 2 adjacent motors in the 1D line case, when the intensity of 2 adjacent motors changes in a specific pattern over time, people can perceive an illusory tactile sensation moving continuously between the 2 motors, not a discrete sensation. So we developed further to create an illusion among 3 motors arranged in a triangle 2D area, which we previously applied the same techniques to the haptic vest. And now we are bringing that. Now we brought that to the haptic gloves too. So let's watch a short video explaining the haptic illusion.
Increasing the pixel density of a computer screen, we need to increase the number of tactile feedback. We have developed a tactile illusion algorithm that creates elusive tactile experience within the 2D array of motors.
With this haptic illusion algorithm applied to the variation of the finger pad and the palm motors, now you can it allows us to create a tactile illusion even where there's no motors. Even, I mean, it is not 100% like proved, but you can even imagine that you have some feeling in even outside of your hand, in between the fingers. Now, so therefore, as a result, you can now, developers can now use the entire hand, not only just the fingers or like palms. Now, developer can use entire hand, just like a haptic canvas, without considering the exact location of the motor itself. To help developers to easily create those kind of complex and diverse haptic patterns, we provide this kind of haptic authoring tool called bHaptics Designer. In this software, you can just not only just control the individual motors, but also you can create like free-flowing patterns using the free path mode, or it has a various of different modes and different kind of effects. So that just like using the Adobe Premiere or Adobe Photoshop, you can create your own haptic pattern with various functions inside. And in the timeline at the bottom, you can adjust the duration of each effect and combine the multiple effects into one haptic effect to create a single complex sensation. The TactGlove DK3 is compatible with most devices that support camera-based hand tracking, such as MetaQuest 3, Apple Vision Pro, Galaxy XR, and forthcoming Picos 2. And well, honestly speaking, it is true that wearing the glove slightly reduces the accuracy of the hand tracking compared to the bare hands, but nevertheless, as you can just try out at our booth down the floor, this reduced accuracy is still completely manageable, I would say, and this added immersion enhances the overall experience much further. So we believe that TactGlove DK3 can provide a great value to those of using XR or spatial computing devices for job training, medical, or military training, or simulation, and social VR, and research like HCI. Well, while it may not be comparable to the real-life feeling, but it definitely improves the accuracy and confidence and the realism of the manipulation task. So if you're interested, just feel free to contact us at any time for collaborations. The TactGlove DK3 is currently available for pre-order. Shipping will begin on June 29th. And also, last but not least, there's anyone here who hasn't really tried our demo yet, please come by our booth at the floor down, like by today. And and thank you for listening to my presentation. And if you have any questions, please feel free to ask. Yeah, thank you.
Thank you so much. If anybody has any questions, raise your hand and I'll bring the, okay.
First, thank you for the presentation. What booth are you at?
Right next to the Arbor XR, and there's a Samsung booth out there. So
you don't know the booth number?
Yes, sorry.
Okay.
But you can just locate us based on the color. It's yellow over there.
Any other questions? All right, thank you very much.